much for inviting me to join your research team. That was a very big moment for me, and it was in 2016. And in semester 2, the project has expanded tremendously, not just in terms of the scope of implementation, but it also expanded in terms of the research questions that we are posing and trying to look for. So with the support from MathsUoA Northern Hub, we got some money to run this project. And now the team was consisting of 4 lecturers from AUT and the University of Auckland. The implementation of the intervention was rolled out on stage 2 maths and physics courses, and for the University of Auckland, more specifically, was done in MathsUoA, which is a stage 2 course, but as lecturers would know, most students take it in the 2nd semester of their 1st year. So they've been around at the university for a while, but not too long. The questions and the goals and aims we're trying to attack is to improve employability prospects of tertiary graduates. It's linked to what Sergiy was talking about, all this innovation that is expected from STEM graduates nowadays, not just content knowledge, and all these drivers we can see in many higher education institutions revising their graduate attributes. Julie and Duncan were involved in major revision of graduate attributes for Faculty of Science, also thinking about those aspects of what kind of skills our graduates have to be ready for the workforce of the future. So from our point of view, we were trying to develop students' capabilities to solve non-routine problems in contexts that are relevant to the workforce of the future, not just in the context of our content-driven curriculum. And so we conceptualize the main phenomena of our study through the framework of motivational influences of transfer of learning. So this work has been done by educational psychologists. Now, motivational transfer influences and transfer of learning, especially transfer of learning, has been an issue that's been researched by many educational psychologists for about 100 years. It's a huge body of knowledge. And also motivational factors that drive human behavior is also a huge part of those social studies. And so they were put together by this framework. So the transfer refers to whether or not and how students access and apply their learning in novel contexts. That's what we are after. So a tool for our analysis aligns very well with one of the four constructs, motivational constructs. So those 4 constructs, namely, are achievement goals, interest, intentional transfer, and for us is self-efficacy. So this is the construct that we're using as a tool to shape our data analysis and conduct our research. So I have to say that, and would you agree with me, that in today's world, the financial and human investment in formal education is grounded on this assumption that these generic thinking skills somehow will be transferred into the outside of academia spheres once those graduates leave academia, right? This is the main premise. So we're talking about transfer of learning. So this is our central phenomenon we are studying, using the tool of self-efficacy. So this is our lens. We're trying to look at the mechanisms that are involved in transfer of learning in the context of non-routine problem solving. So more specifically, in the context of transfer, self-efficacy usually refers to confidence in the ability to do or learn a skill that can transfer to other domains. So our data collection consisted of retrospective reports from 137 students from AUT and UoA, answering 10 questions from the questionnaire, and we also conducted in-depth interview with 5 participants. So what we have found is, so we looked at 2 categorical variables. So we're looking at confidence mainly, and we are looking at confidence as a categorical variable measured against their grade in prerequisite mathematics scores. So what you can see in front of you is a bar chart representing 3 categories: A grade band, B grade band, C grade band. So by that we mean their grade in the prerequisite mathematics scores. They all have to pass mathematics course to be able to take the course in which we rolled out the intervention. So A grade means A minus, A and A plus combined together. So those are the 3 categories that we're looking at. In the colors, color coding, you can see blue is the proportion of yes. They said, yes, we are confident in solving non-routine problems. And orange is no, we're not confident. We're on the chi-square test for independence on it, with the statistics of chi-square is just over 1, p-value is half, so the result is not significant increase in the p-value, so that means no association between the categorical variables is observed. So in plain language, it means performance in math does not say anything about confidence in solving non-routine problems, which we have found similar perceptions from the past, and also as reported in previous research as well. So that is nothing new, but we just wanted to make sure that is confirmed to us as well. So what is new is, again, we're looking at confidence, and we're looking now against a different categorical variable. Now we're splitting them into 4 groups based on their performance in solving those non-routine puzzles during the semester. So this questionnaire was administered at the end of the semester. So they were able to say in which category they belong. So from 0 to 25%, puzzles solved, from 25 to 50, 50 to 75, and the last one is from 75 to 100 solved. And in red, you can see the proportion of the students for each category saying, yes, we are confident in solving non-routine problems. So we're on the same chi-square test for independence, and with the statistics with 3 degrees of freedom, we get 33.2 is a p-value of 1 millionth. So the result is significant at p-value of 0.5, implying that an association between the 2 categorical variables has been observed. So we also looked at the effect size of this association, now measured by Kramer's V, and it is 0.53. Now, Kramer's V is varied from 0 to 1, with 0.53, meaning it is substantial. So associating moderate association has been observed. So what does it mean? Remember, we are looking at confidence in solving non-routine problems as a tool to measure or inform us about self-efficacy, which from the educational psychology is known to be a predictor of transfer of learning. I don't have time to talk about the mechanisms by which self-efficacy is the factor in the transfer of learning, but what we can say is we observed that there is an association between students' performance in solving non-routine problems with their confidence in solving non-routine problems. But I also want to point out that the intervention itself was a very small-scale intervention. All we did was we spent 5 to 7 minutes of activity on inserting these puzzles into our lectures. In the middle of lectures quite often, well, for us we were, 5 to 7 minutes per week. That was a very little investment. It's a very small-scale intervention. So, basing our analysis on this framework of motivational influences on the transfer of learning, we demonstrated how we can improve students' confidence in solving non-routine problems by very small-scale intervention. And we're suggesting that there is a positive effect on students' self-efficacy in the context of transfer of learning to novel domains. We also showcase how it can be done as a small-scale tuning of your teaching and learning practices at the university level. And it is appropriate to mention that this method is amenable to scaling up across STEM curriculum. We can do it, anyone can do it, just insert some puzzles into your teaching. It's just as a break. So we're saying that this can help develop students' capabilities to solve non-retail problems that are relevant to the workforce of the future. Those are the things that employers are expecting from our graduates to have. And most excitingly, putting all the three pilot studies together, the results and findings, and working really hard, Sergiy mostly, has applied for this major grant from Teaching and Learning Research Initiative. We were given this grant, and our team has expanded significantly, again, in the scope of the implementation, and also the number of researchers. So this is our research team. We've got Mike Thomas from here, and Julia Novak sitting over there, who is the Associate Dean of Teaching and Learning from Faculty of Science. And we also have Jason Stevens from the Faculty of Education. He's an educational psychologist. And our lecturers, the team of our lecturers who were implementing this intervention was about a dozen. So 12 people were actively doing this intervention in their classrooms. And it was a project that involved 5 groups of students from 4 diverse tertiary institutions. So we were affecting over 700 students with this intervention at AUT, several courses from AUT, University of Auckland, MathsUoA, our largest stage 2 course for the Maths department. We have Johnny and Nicolette who are doing puzzles as well, independent this trial. And MIT, not the one in the US, our MIT, and also Fitteria. So those were the 4 tertiary institutions who were involved in this trial. And Sergiy was managing the whole thing, so it still is. Yes. And so the intervention is very much the same as we used in the first 3 pilot trials. 5 minutes per lecture is a break in the middle. But we set the requirements 5 to 7 minutes per week, and the lecturers were free to choose how they do it. Some of them just do it in one go, some of them spread it into 3 lectures. And the data collection is quite extensive. We are trying to measure a lot of things, so for that we have done a pre-test survey, questionnaire, we've done a post-test, and we're trying to figure out the effect or the impact of this intervention on many things. And so the test we are using is cognitive reflection test, conversion thinking, diversion thinking test, also trying to measure creativity. And we also ran video recorded focus groups, and we also did observations of lectures. So future research is quite exciting. We'll be busy analyzing this data for years. So we want to evaluate the relationship between the ability to solve puzzles and course performance. We want to measure creativity, as I mentioned before. We want to investigate the effect of engagement and attendance, and we want to analyze the impact on students' decision to continue with their studies. So we're looking at retention as being impacted by this. And also, we want to measure the cognitive dimension of the student engagement. So that's a tricky one. that contains investment in learning, perseverance in the face of challenges, the use of deep rather than superficial strategies, and the metacognitive factors. So, thank you all, and Sergiy.